All right, this video is for Mrs. Vaughn's geometry class. We're going to cover section 1.2, undefined terms and definitions. And this video is for y'all's lesson on Tuesday, August 31st. So try to keep this quick if possible. There's a lot of terms to go through. You all got a vocabulary worksheet that I'd like for you to have handy while I go through this lesson. And try to fill out some of the definitions as we go through. I will review that at the end because there's a lot of probably very new and confusing words that we need to make sure that we understand. So first, when we talk about studying geometry, you need to understand some basic terms that we're just going to use over and over and then go more in depth in. So you've got to understand them now so that you have the foundation you need to understand some of the more complex concepts that we're going to discuss later. So when we talk about definitions, there's five main things that those definitions need, five main criteria, I guess, that those definitions need to meet in order to be good definitions and useful. They need to be accurate. So they need to state terms being defined and clearly communicate the concept. They need to be understandable. So you use words that are previously defined and clearly understood. They also need to be reversible. So the definition identifies the class to which the object belongs and its distinguishing characteristics. And that needs to be concise, not wordy and redundant. And that needs to be objective. It avoids emotional words, figures of speech, or limitations of time and space. And they do give you some examples of that. I'm probably going to go into those more in the next lesson when we finish up this section. But for now, let's go ahead and go into a couple of the first terms that we need to understand. These are on page 7. There's a box there in sort of an orangey yellow that has term, description, an illustration, and a notation. This would be a phenomenal piece of information to make sure you have either on a note card or in your notes, very neatly written, because it's going to be something you're going to see going through the rest of the class. So the first one is point. So when we talk about a point, by definition, it's a dot or location with no length, width, or thickness. It is simply a location in space. And so we illustrate that with a dot, usually on a line or a graph. And then we also make sure we graph it with a label. The labels are always, the labels for a point are always capital letters. And the notation is point P, like in this case. A line, obviously, we kind of know what a line is, but a line is going to be a straight set of points extending indefinitely in one dimension with no width or thickness. So, it doesn't have a width or thickness, very one-dimensional. But like you think of a line as simply just a collection of all of the infinite number of points that can exist on that line. So it's just sort of a straight set of points. We can put a point anywhere on there to measure a coordinate. So we represent that obviously with a line, and a line will always have a minimum of 2 points. And the example they've given you is C and D. And then they've labeled the line with a lowercase m. And when we represent a line, you're always going to either write line CD, or, this is important, make sure when you put the CD together that you put that sort of line symbol above it, so you know you're representing a line. And then, of course, in this case, if you didn't have any points on it, you could also call it line M. All right, and then the last thing that we want to look at, this is a plane. So this is bringing in a more two-dimensional surface. It's a flat surface made of points extending indefinitely in 2 dimensions, but it still has no thickness. The thickness doesn't come until you've moved into 3 dimensions. Let's just try to create this. I am not even remotely an artist. And again, in a plane, you're going to have 3 or more points to sort of create a length and a width. F, H, and G, just to keep it consistent with y'all's example. And this is plane K, lowercase. And so you can, there's no real symbol you use for that, but you would write plane K or plane FGH. So the plane is made from the points that exist on it. So they're not exactly definitions, but they do help you visualize the concepts of a point, a line, and a plane, and they're going to help you later. So let's get more in depth a little bit about some of the other geometric terms that depend on these 3 concepts. This is the definitions that you have in the blue box there. We have collinear points, which are points that lie on the same line. Like, for example, if you look over here up on the screen, line CD, you have the points C and D that exist on line M. Therefore, those C and D are collinear points. And you can think of like coworker, you both work at the same place. Collinear, you both live and exist on the same line. Linear is line. Concurrent lines are lines who intersect at a single point. So let's look at example 2. And again, here goes Miss Vaughn's horrible artistic ability. It's all right. I am comfortable with my flaws here. All right. So we've got all kinds of lines going on here. We have line K that is perpendicular. We have line L, line M, and N. Those are parallel to each other. And then we have some points here. So we have point T, we have point R, S, random little V in the middle, and W. All right, so when we're talking about having 3 collinear points, if they're collinear, they exist on the same line. Therefore, it must be the T, V, and S that exist on line L. So our collinear points are T, V, and S. Forgot how to spell. Okay, and then we have 3 non-collinear, because again, you always have sort of an opposite concept to many of these points. You have a non-collinear point are obviously points that don't lie on the same line. So if you look at example 2 again, you have R that exists on line K and M, and then you have V, which only exists on line L, and W that only exists on line N. So R, V, and W are non-collinear. Points. And then lastly, we have 3 concurrent lines. So again, a concurrent line is a line whose intersection is a single point. And you can see right here at point T, we have K, let's see, K, L, and N. Those 3 lines all intersect or meet at point T. Therefore, lines K, L, and N are all 3 concurrent, because at some point, all 3 lines exist in the same point in space at the same time. That's what that concurrent means. All right, so let's move on to 8. Page 8, you've got a whole nother list of definitions here. We're looking at more of the planes and then lines that exist, lines and points that exist on planes. So let's go through these really quick. So dog, go, don't, sorry. Coplanar points are points that lie in the same plane. Again, look at our example of plane up here. And you have F, H, and G all exist on plane K. Therefore, F, H, and G are coplanar points. And then you have the opposite, non-coplanar points do not lie on the same plane. Usually you'll see that when you start working with three-dimensional objects and like a cube, you're going to have a lot. 1, 2, 3, 4, 5, 6. What is it? 6 different planes making up that cube. And then coplanar lines are lines that lie in the same plane. Skewed lines are lines that are not coplanar, so they don't share the same plane. Parallel lines are coplanar lines that do not intersect. And when we work with parallel lines, this should look familiar, that we use the symbol, the straight up and down when we say that two lines are parallel. And so that symbol means is parallel to. So if I said like line CD is parallel to line AB, then you can expect the two to look something like this, where you have C, D, and A, B, right? They're perfectly parallel to each other. All right, so example 3 gives us a cube. So a cube gives us an option to look at a multiplanar object. Oh, let's see here. Cube is about the only thing I can draw. All right, so we have our cube and we have, there's multiple points on it there. And you've got 4 coplanar points. So when you look at that, you can see that pretty much any corner of any of the planes, so D, where'd they go here? D, C, K, and L are all on the same plane. B's, if we're looking at 4 non-coplanar points, so they don't exist on the same line, then we look at A is in the top, that top corner there, and then B we have on the back plane. C is on the side, it's on a right side plane, and then you have K, which is on that front middle plane. So those, none of those exist though on the same plane. They're different heights, so they're three-dimensional compared to each other. They would not all exist together in a two-dimensional space. All right, so if we're looking for 2 pairs of coplanar lines, then you should have a couple of options. Yeah, so we have A and B, and then B and C. Those are coplanar lines. And then A and D, here kind of on the front of the cube on example 3, and E and H, also coplanar lines. And there are additional ones. We're just kind of picking 2 here. And then of course, D asks us for parallel lines. You've got lots of different options to pull from. As far as parallel lines, you have the AB is parallel to DC. AD is parallel to FG. EH is parallel to BC. Like there's more than just what they're giving you. So don't feel like because you're seeing other options that they're not also parallel. Let's see. Now, 2 pairs of skew lines. This concept of a skew line can sometimes be confusing. So look at option E on example C, and they have AB, which is in that top left corner, and DH. So you can see how AB and DH at no point are coplanar. One is going sort of forwards and backwards over on the right side, and one is going up and down vertical on the right side. So very, very different. And then last, you have parallel planes. So this plane ABC, that top of the cube, is parallel to the bottom, but also the left is parallel to the right, and the front is parallel to the back. So you do have multiple options there. Okay, so that kind of gets us through the lesson portion of this. I wanted to go over a couple of additional problems. So these are not in your book. Let's see. But they do, a lot of these are referencing the figure from example 2. So if you go back to page 7 and kind of look at the bottom example 2 there, I've got a couple of questions I want you to look at. So go ahead and make sure you have these in your notes and draw that diagram that's in example 2 as well. No, I know I already did it once, but I'm just going to do it one more time so we have it in front of us. There's one. There's a line. And one last one here. All right, so we have line K, we have line L, line L, M, and N. Why are you biting my foot? Go away, cat. And then we have point R, where line M and K are concurrent. Line T, point T, sorry. Point V, point S, and point W. All right, so the question, oh, I put a 6 there. Okay, number 1, are points R and W collinear? All right, so we have R up here, the intersection of M and K. We have W that exists down here on line N. So are they collinear? Now remember, a line can be drawn through any 2 points. So just because we don't have a line here doesn't mean that those 2 aren't collinear. We could, oh, excuse me. I hate when it does that. If you draw a line here, does that work? Yes, it does. So anytime you have 2 points that exist on the same plane, well, actually multiple points, yeah. So anytime you have 2 points, you can create a line by definition of a line. Therefore, R and W are collinear. All right, let's look at another one. Number 2, are lines M and N concurrent? Okay, so again, look at your definitions. Concurrent means that 2 lines will intersect in a single point. These 2 lines are parallel. Do parallel lines ever intersect? No. Therefore, lines M and N, at no point can they be concurrent. All right, so the last 3 questions are going to be about the figure in example 3. I'm going to have to draw. Okay. Make it bigger so I can label it without making a mess. I'm not good at this. I know they have dotted lines. I can't quite do that. So this is E, A, J, B, C, and D. And then we have point K here in the middle, L down here, point G, and point H. Did I get them all? A, B, C, D, E. Oh, what? Oh, there's F. I know I missed one. E, F, G, H. I don't know why they don't like to use I, but they totally skipped it. And then J, L. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, good deal. Okay, so let's look at my questions about this figure. So if I ask R and FG coplanar. All right, so what I'm asking is, are lines AD and FG coplanar? Well, anybody want to take a guess? Let's look at the definition for coplanar. Coplanar lines are lines that lie in the same plane. So you can create a plane that exists, that kind of intersects this cube, this horrible cube that I've drawn. All right, so let's pretend that there's like a slice here that has sliced through diagonally across this cube. That is a plane. It's a two-dimensional plane that's cutting through diagonally across that cube. Once you create that plane, because you do have the lines A and D and F and G that exist on that diagonal plane, they are coplanar. So the answer to this is yes. So let's look at something else. Okay, let's look at another one. Number 4, R, AD, and CG coplanar. All right, so let's look at this. So we have AD, and then we have CG. All right, so because you have one horizontally and one vertically, they cannot exist on a flat plane. So you think about a plane as like a sheet of glass, like it's one two-dimensional plane, and you cannot have a horizontal line and a vertical line be able to lay flat in 2 dimensions. By being horizontal and vertical, you have created a 3-dimension. Therefore, the answer to this is no. Those two are skew lines. All right, let's look at one more. Number 5. Are points A, D, and F coplanar? All right, so we got A, D, and F. Well, if you think about it, in number 3, we just said that line AD and line FG are coplanar lines. Therefore, the points on those lines would have to also be coplanar points, because again, they're existing on the same plane, and it still is within the 2-dimensional restrictions of existing on a plane. Therefore, absolutely. So your answer is yes. I'm going to give you the reason in a little better words than me just talking about it. It's because any 3 non-collinear points lie in a unique plane. Let's go back to our definitions real quick. Where was I? Here we go. All right, so remember, a point is a single location in space, right? A line requires 2 points. Any 2 points can create a line between them. A plane must have, to go from 1-dimensional to 2-dimensional, a plane must have 3 points. a minimum of 3 points. So as long as you only have 3 points, those 3 points can create a plane. Yeah, okay. All right, let's go on to the vocabulary and just make sure that you guys got everything you need before we talk about the homework assignment. New share. Okay, here we go. All right, so I did this as matching. So you have the definitions and the terms all on one page already. These still would be great things to write down, especially if you find that you're a kinesthetic learner or visual learner. It will help you just writing them out. All right, so number one, a dot or location with no length, width, or thickness, a location in space. Hopefully we figured out that that is a line. There it is, D. I'm sorry, not a line. What am I talking about? A point, J. Okay. A straight set of points extending infinitely in one dimension with no width or thickness. Again, that's our line. 3, a flat surface made of points extending infinitely in 2 dimensions with no thickness. Think of it again like a sheet of glass. It's a flat surface, very two-dimensional. That's our plane. All right, if we have points that lie on the same line, then we are looking at collinear points. All right. And points that do not lie on the same line, these are non-collinear points. Easy enough, right? Okay, lines that are not coplanar. So if we have lines that are not coplanar, we are looking at, that's what we use, well, let me get my draw to work, skew lines. Again, go back to those definitions on page 8. A skew line is a line that is not coplanar. Now, lines whose intersection is a single point are what we call concurrent lines. They exist in the same point in space at the same time. Okay, points that lie in the same plane are coplane. Where am I? I'm out of points. Let's see, number 8. I think I missed something because I feel like that's probably supposed to say coplanar points. Is C. Let's see. Coplanar points are points that lie on the same plane. And coplanar lines are lines that lie on the same plane. So I think I forgot coplanar points. Planes, points. Just change that to points. Sorry. All right, coplanar lines that do not intersect are non-coplanar. Did I do the same thing? I did. Those are non-coplanar points. Wait, coplanar lines that do not intersect. I don't know why I'm trying to do this at midnight. Do I have a non-coplanar line? Number 9. Oh, those are, y'all, too tired. Parallel. Those are my parallel lines. G. Right. Coplanar lines that do not intersect run parallel to each other. All right. Planes that do not intersect are parallel planes. H. And then points that do not lie in the same plane is F by non-coplanar points. So I think what I did there, so it's F. Where else did I use F? I didn't. I just marked through it for no reason. All righty. Sorry, guys. It's a little bit confusing, but I wanted to make sure you have the right answer. So you should have J. Number 1 is J. Number 2 is D, a line. Number 3 is I, a plane. Number 4 is A, a collinear point. They lie on the same line. Number 5 is E, non-collinear points because they do not lie on the same line. Number 6 is K. Your skew lines are lines that are not